Greetings, Earthlings. So now VCF West 2019 is over. I showed the 6809 based arcade game running TacoBot. 2018 I showed the stupid computer running TacoBot and other things. So the question now is, what's on tap for 2020? What's the next project? And although I have something in mind, you don't get to vote on this, but we'll go through some options. I have more 6809s. Here they are. So I could do something 6809 based, but I've done that. It's a nice processor. I like it, but I want to do something different. So what else? Well, I've got these 2901s. I could do a bit slice. I only have two of them. So I could do some 8-bit machine or 16-bit machine with using 2 cycles or something along those lines. This is a 2914, which is an interrupt controller, I think. So those are 77 date codes. That's cool. But no, I don't think that's quite the right thing either. Well, I've got this. This is a Zilog Z8671. It's an 8-bit Z8 microprocessor with tiny BASIC built into it. 82 date code. But I've already built a machine around one of these, and so that's unexciting to me as well. Well, moving on. Ooh, now we're getting somewhere. I've got some Z8000s. These are non-segmented, 6 megahertz Z8002s. I also have a segmented one right there. It handles a larger address space, is what this does. There's another Z8002. Parallel and serial chips, and this is a CRT controller. So we could do something interesting with that. And that's 16-bit microprocessor. So that's much more interesting because I've done 8-bit, I've done 12-bit. Or we could go like to sort of almost 32-bit. We've got a 68,000. This is a Toshiba version here. 12 megahertz. Looks like a 2000 date code. Or a National Semiconductor 32016. And that's the clock generator chip for the National. Let's see, those are 89s. And that's a 2000, I think. So that has interesting possibilities. Now, what I recall on, I should go back and mention on Zilog. I actually interviewed at Zilog in my youth to work on Z8000 processor software. However, it was right around the time a bunch of people, and it seemed like all the people I interviewed with, left to start Ungerman Bass. So that didn't happen. This was originally a Motorola design. So it's, sort of the next generation after the 6809, which would make that interesting. National. I can't remember if I actually interviewed with National or not when they were designing this chip. What I remember, so I at least talked to them. And what I remember was that the chip design was being done in Israel and that they were going to run Unix on it. And so that was uninteresting to me. So didn't do that. So that leaves one more very interesting old chip. This particular one has a 1988 date code, but this originally came out, well, the original version of this came out in 1978. This is an upgraded, the second version, if you will, second release. This is a Fairchild F9445. And the original was the 9440. This implements a Data General Nova instruction set on a chip. And so it's possible to emulate a Nova computer. And that's what I'm working on. That's what I'm going to do. Now, there's easy ways and hard ways to do this. The easy way would just be to, build like a 6-chip design, use memory mapped I/O and such, and that wouldn't be very interesting. What I really want to do is I want to be able to run RDOS on it. This was Data General, let's see. Data General's operating system for the Nova, and dates back to early to mid 70s. Yeah, this was published in 75. This particular revision. So there's a free version of RDOS out there. It's free for non-commercial use. The problem is, if you want to consider it a problem, the challenge is that you've got to implement the not just the Nova, instruction set, but the I/O configuration as well, and emulate disk drives and minimally hard disk, terminal, teletype in, teletype out. We called them teletypes back in the days because they were teletypes. Now you call them serial ports or whatever. So the I/O, the Nova has a unique I/O architecture, and so emulating that, which is obviously not memory mapped, because that wouldn't be unique, and it would make it too easy. So emulating that complicates the thing, which makes it interesting. It means it will probably take about a year to get something up and running. So that's the plan. I'll do another video, follow up to this one, talking about the Nova architecture. But the Nova was the first computer that I used. That was back in, I don't even want to say when. The first computer I used was a Data General Nova 820, and it was running RDOS, and or Rhodos, as one guy called it. But real-time disk operating system, RDOS. Yeah, it also had a number of languages: BASIC, Fortran, Algol, good assembler. Yeah, so that's the plan. Oh yeah, and one other thing I forgot. I actually interviewed with Fairchild back in the day when the 9440, the predecessor to this chip, first came out. I interviewed with them to develop software for it that they would be supplying, with their development boards and whatnot. Now, as I recall, they wanted to hire me, and I actually got a letter from them saying, please call so-and-so, one of the managers I had interviewed with, concerning an offer of employment. Well, I called him up, and he said, yeah, well, I just wanted to, keep in touch, or whatever. I'm like, that's weird. It was shortly thereafter that Schlumberger bought Fairchild. So I think that probably they were in the process of that at that time, and all the recs got frozen. And so that's why I never ended up working for Fairchild.